podcast. So, what did you think of the book?
I actually really liked it, but I'm not gonna lie. I kind of already knew most of it because I'm majoring in statistics at college.
I was about to say, I did not like the book.
Really?
Not so much, I don't know, not so much that it wasn't important. But again, I just knew, like, I feel like it was just so basic.
Yeah, that's one thing I was disappointed in. It like didn't go too deep into like statistical sciences.
Like, and you said it was recommended by because that's why we picked it. So it was recommended by your statistics professor?
Yeah, it was. They gave me like a couple books and I was like, okay, let's see which one would be most interesting. And I was like, all right, that one sounds pretty good. But
does your statistics professor just think you guys didn't learn anything? Because I feel like this book was like, I mean, I feel like I would have known everything from my like statistics 101 class that I took in college. Not even like a high level probability class. Because I mean, I took quite a few math classes in my stretch trying to figure out what I was going to do with my life. And I think for me, the one that I actually think I learned the most in was my probability class. And it was like a 6,000 level probability class. Mm-hmm. It was pretty interesting on the way that you can actually get probabilities and what probabilities really mean, not just, straight percentages. And this didn't even go into that. Like, it didn't even scratch the surface of that class.
Yeah, for me, it was like anyone who thinks critically knows all this, basically. It's like, oh, look at the chart. Like, obviously the chart's lying. It's like it doesn't show the actual growth because it goes from like 20 billion to like 22 billion instead of 0 to 22 billion. So like it's going to be super more dramatic.
Yeah, I mean, there was a whole chapter on make sure that they graph the whole thing, not only half the thing. I was like, all right. I mean, I get that that's important, but it was also like, again, like you said, it was critical thinking for a lot of this stuff. I mean, there were definitely some things in there that had to do with statistics, but I felt like a lot of it was just critical thinking. Like, I was kind of disappointed.
I feel like that just shows how times have changed because I'm pretty sure this book was written.
Does it say on here? I mean, I do Audible for most stuff, but does it say what year it was written or published even?
Let me look. So this was published in 1954. So
holy
this
cow.
Is an old book. And so I feel like it could be critical thinking to us, but for people back then who had no idea and like statistics wasn't.
Well, and like not the internet, because now I'm trying to think of like the way that the way that I learned critical thinking was probably looking at something, being like, that seems a little fishy, and then hitting the internet and realizing, oh, this person's lying.
Yeah.
Whereas in 1950, it would have been like, do I want to go to the library?
Yeah.
Nope.
Statistics.
I'll just trust this guy.
Yeah. And like the news was like, how is there any way to fact check the news back then? Like you look like right now, the fires in Hawaii, super sad, like super bad, but like, what's happening because you can at least like see where this one's like, oh, back then it was like, we're doing better. Here's the numbers. And it's like all skewed. And you're like, I guess we're doing better. Like,
yeah, I know. Cause you hear a lot about, you hear a lot about the news. I feel like people trust the news less now than ever. Mm-hmm. And like all the podcasters and everything that I listen to, they all say, news is going away. Like nothing's happening, like all this stuff. And I just wonder if it's always been like that and people just never knew, or are they really just lying to us? Because again, if this was a book that people didn't know while they were watching the news, then I feel like, oh boy, they could have just been pulling it over your eyes for years.
Yeah. Something that was eye-opening to me like studying statistics, and kind of my running joke in the department is the more I learn about statistics, the more I don't trust any statistic. Like if anyone says, well, statistically, I immediately go in my mindset, well, I'm going to prove you that this statistic doesn't mean anything. And since I study this and I'm trying to get a PhD in statistics, like I'm going to do it. And like in my stat 340, which is like the junior class, probability and inference, which is like super hard. Those are the two hardest classes, is probability and inference 1 and 2 at BYU.
Yeah, probability is not easy.
No.
I remember taking that class and I signed up for it. And again, it's like a 5,000-6,000 level class. It was after I had taken Calc 1, 2, 3, taken theory classes, all sorts of proof classes. And then it was like, all right, I just need math electives now. So I was like, okay, I'll take probability. That seems easy.
Yeah.
It was not like probability is so hard when it's not, flipping a coin 50-50. Like it gets really difficult. The amount of like variables and things that you can add, like that was a hard class.
Yeah. The thing that broke my mind was, and then I'll get back to my point about that class, but there's a game show and they show the probability of like there's 3 doors and one door has a goat behind it. And then so what happens is you choose a door and then they open one of the doors, so then the one that you didn't choose didn't have the goat. And so basically now there's 2 doors left.
So it should be 50-50.
It should be 50-50, but it's 2/3 if you switch. Like there you have a 2/3 probability if you switch doors that you'll get the goat, which makes no sense to me. Like double the percentage of chance. It didn't, like, I still struggle to wrap my hand around the fact, like, if I switch doors, I have twice, like, the likelihood to get the goat. And, like, the whole thing was if you got the goat, then you got a, like, super nice car. Like, that was the whole game show. And so, like, we did, like, a simulator. My professor's like, who doesn't believe me? And I, like, raised my hand. I was like, that doesn't seem like that doesn't make any sense. It should be 1/3 or 50-50. There's no way it's 2/3. And, like, we ran, like, 10,000 simulations through the simulator. Sure enough, it, like, went to 75%. Or not 75, 66, I guess. But I was like, oh, my gosh, that doesn't make any sense. But in my probability class, we went through every single day. And this is like 3 times a week we're having this. Every day we chose a different news article and we pulled up a graph. It didn't matter, like CNN, Fox, like all the different outlets, even some independent ones. And we just obliterated some of their statistics. Like, all right, what's wrong with this? And we just, like, for 10 minutes talked about how their statistics were absolutely wrong and their figures and stuff and purposefully deceitful. And it's like,
I mean, everything is. Because while reading this book, I was scrolling through Instagram and something came up on, like, some news outlet that I follow on Instagram. And it was the CEO of, I think it was UPS, that announced that it was like, we are now going to be paying all of our drivers $170,000 in, and then it was like salary and benefits. And I was reading this and I was like, man, I should just give up the podcast, become a UPS driver. Freak, man, $170,000. And then I was thinking, I was like, well, I mean, it's awfully convenient that he threw the word benefits in there too.
Yep.
You know, like, you're not just paying these people $170,000. Now you're lumping in benefits. And I'm sure that they're not just lumping in, like, traditional benefits, you know, like vacation, dental, vision, health insurance. I'm sure it's now like, well, how much benefit do they get now that they can ship stuff for free with UPS? Let's throw that number in there.
Yeah.
You know, like, what's the benefit for, like, what can we give them that has a high value benefit that we can add to this number, but 99% of people aren't going to take advantage of it. You know, like different things like that. Like a gym in office for UPS drivers. Oh, that's probably like $40 a month. We'll count that towards the benefit. You know what I mean? And it's just, I was like critically thinking, and in the comments, people were like, man, I need to work at UPS. Man, I need to work at UPS. And then there was one guy in the comments that was like, I work for UPS and my salary is not changing.
Well, even with that, it's like, is that the median or the mean or even like the mode? And like,
Yeah.
in what area? Like if you're in LA or like California or New York and you're making 170 total, including benefits, you're not going to be living too well. Whereas if you go to like Texas or Florida or like somewhere, Kansas, and you're making 170 with benefits, that could be great.
You're
But,
balling.
like, they're probably going to lowball them both and then say 170 because they'll pay the guy in California, let's say like 250 in pay and benefits, and then the guy in Kansas 60K in benefits and pay.
Well, yeah, and that was the thing also is like he said the average worker will make 170,000 or something. And then it's like, I mean, does the CEO's salary count in your average? Like, you're just bringing up the whole thing like, oh, yeah, we're going to pay our CEO $2.5 million, and then we're just going to count that within the average.
Yeah.
You know, it's just, you know, I was just like, wow, that is a spot on example of this book and just the critical thinking there. But again, I guess I did fall for the trick because I was like, holy crap. I could work for UPS. I could deliver books. I could deliver packages all day and just listen to podcasts and have my AirPods in.
Yeah.
It's chill.
The problem is what this book talked about a little, I think, with all of this is that like the damage is done before you even prove that it's wrong. You know, like an advertising person will throw out a crazy headline and like, oh, this toothpaste is 26% more effective against like cavities, and we did a study, and like the book talked about how the study was done by an independent group. Doesn't mean anything. It could have been
the toothpaste one killed me because it was like the study was 4 people. It was like,
and they did it repeatedly until they got the results they wanted.
Yeah,
and then they slapped it on a label. Then the advertising people threw it out there, and then eventually they had to take it down because obviously it's a lie, but the damage had been done. Like it's already circulated through the news. Everyone's already done everything. And it's like,
yeah, they reaped the benefit.
Reap the benefits.
No consequences.
Yeah.
Yeah. So before we keep diving into the book, just go ahead and introduce yourself. I always just like to talk a little bit about the book so that people who listen to the first 5 minutes at least get a little interested.
Yeah.
Still trying to reel in an audience. But yeah. So who are you? Why did you choose this book? Some people I let them choose books. Some people I just tell them, like, if there's a book I really want to read, I'm like, we're reading this book. And that's what I'll probably do for the next one. We'll probably read a fun book. Mm-hmm. I'm a little bit nonfictioned out at the moment. Between this book, Adam's book, and then The Rise and Fall. I went to Barnes & Noble yesterday with Olivia. And I was just looking around at books, and I was like, I wonder if they have The Rise and Fall of the Third Reich in Barnes & Noble. And I found it. Dude, I kid you not. It is literally like this big. I grabbed it, and I handed it to Olivia, and she was like, is this the book you just read? And I was like, dude, it is so long. Like, I cannot emphasize that enough. It is absurdly long. Very good. Very thorough. Oh my gosh, that book was humongous. Yeah. So I'm a little nonfiction out. The next book that we do will definitely be a fun book. I still want to read, like, I don't know, Dune or...
I love Dune. I read that. I'm reading this. Like, all my buddies are reading it. I've already read it. Waiting for the second part to come out.
I know.
Dune is a good one.
I know. I want to read that one. There's a handful of other ones. But yeah. So you chose this book. Explain a little bit as to, you know, kind of why. Your name is Matthew. You're my brother.
Yeah, brother.
Yeah, I have a couple brothers. Adam's the other one.
Yeah. I'm in college currently, college senior for statistics with an emphasis in data science, a minor in mathematics.
So you graduate in April?
I graduate in April. I'm applying to PhD programs this fall, and then if I don't get in, well, I don't know. I'll be applying to master's programs as well. The following, like, January, February time. And so
what do you want to do with, I mean, because again, my path through education was all over the place. Like, I started off pre-med, but the furthest I got outside of my degree, which is economics, the furthest that I got was definitely down the path of math. I think I needed, like, I I think I needed less than 20 credits to graduate with a math degree in conjunction with my economics degree. But then I was like, ugh, I can't take any of these classes online, and I'm not ever stepping foot on that campus ever again. So then I just dropped it. Wasn't worth it. And then just graduated in economics. So I took a lot of math classes, and I'm always very interested with people who study math and what they want to do with it, because unless you're a professor, I feel like the jobs are not as well known. Not that there aren't jobs. They're just like, people are like, what do you do with a math degree?
Yeah. Well, the main thing for me was I really have always enjoyed and been good at math. Like, I remember doing Adam's homework for him, and he's 2 grades higher than me. And I was in like 2nd grade doing his 4th grade homework. Like, that's what I remember. He may not say, he may not confirm that, but I definitely remember that. But basically, kind of like you, I was like, I want to be a doctor, because mom kind of installed that in all of us, where we all needed to be doctors so she could have free healthcare. But
yeah, she was just looking for her ticket.
Yeah, exactly.
One of us was going to pay for her to be in an old folks home.
Yeah. So definitely wanted to do that. And then after taking the college chemistry 1, I chose not to do that very quickly. And then I wanted to do
You only made it through Gen Chem 1?
Oh yeah, I couldn't do it.
Really?
I didn't do bad in the class. Like, I didn't do bad, but I struggled. Like, it was really hard. Like, it did not make sense for me. And so I immediately changed my mind. Biology, I was fine. I got like 102% in that class. Like, 100% on all, because it's just like memorization. But chemistry, I was like, yeah, this makes no sense.
See, that shocks me, because I feel like math is, like, chemistry is more, I guess it's not as much as physics. Physics is basically only math. Like, that is.
Yeah, it's calculus.
Physics is math. It's like applied math. And then you have chemistry, which is a little bit more math. And then you have biology, which is like no math at all. Yeah. So it kind of shocks me that you struggled with the one that's kind of medium math, medium memorization.
It could have been my attention span. I'm not gonna lie. Like, if something I'm not interested in, or like it doesn't click, I just can't focus in class. Like, I'll skip class. Like, I took a linear algebra class. That was my worst math grade, because I just couldn't really focus. It was like so dry, and so I stopped going.
Linear algebra is not, I don't know. I still couldn't tell you what linear algebra is.
See, I could tell you, because I had to, like, it's so applicable in so much like computer science stuff, and I've taken like, I don't know, like 4 computer science classes today.
I guess I took differential equations and linear algebra combined into one class.
Yeah, that's intense. I'm glad I don't have to take diff EQ, because I'm just doing multivariable calculus, and that's as far as I go.
So I don't actually even know what is differential equations and what is linear algebra. I mean, I know what they are. I guess it's one class. But I couldn't tell you at all. But I do know that my diff EQ class, I got an A. And I honestly couldn't tell you how to do anything.
Yeah.
Like, I would go into those tests and I'd look at the paper and be like, all right, well, I'm going to write down what I think he wants, but I have no idea what any of this means. And I just go through like kind of what I've learned, but I was like, like most math made sense to me. I feel like I feel like you and I are very similar in the kind of education department. Like, it just makes sense. Like, I was very good at
teach yourself this stuff on the exam.
All throughout
high school. Never focused on homework, just slept.
Never memorized any sort of formula. If I didn't know it, I was like going back to the basics, and I just basically derive the formula on the back of the paper and then flip it over and be like, all right, I'll just use this because I think it's right.
Yep.
And usually it was. So that was me basically, and I could really understand math until diff EQs. And then I was like, dude, I honestly couldn't tell you what I'm doing here, but I'm doing it, and I'm getting a good grade.
Yeah. My father-in-law, Sean, he went to MIT twice for masters. So he's like a bright dude and like really smart, like real estate developer. Like, who goes to MIT twice? Like,
yeah,
come on. But he said the class he struggled the most with was diff EQ. And he said he was in the TA lab literally for like 5 hours a time. And he was like, I will not leave until I get my homework done and like understand. The TA is like, okay, my hour ended like an hour ago. And it's like, no, I'm not leaving. And so ever since hearing that, I'm like, yeah, I'm good with just Calc 3, multivariable calculus. I don't need to take diff EQ. And so, Yeah, I'm glad I chose statistics because, like, for me, it was always math or something related with math. And the whole reason I chose statistics was because I feel like for me, the jobs were better towards statistics. Like, I know people at my university, like professors, who they worked for, say, what was it? NSA, and they're writing custom algorithms to catch bombs. And, like, my professor literally told me a story where they caught a terrorist based off of his mathematical equations and work. And I'm like, yeah, that's way too much pressure to do math for me. And so I chose statistics because you don't actually use a whole lot of math. You just manipulate it. If you kind of read in the book, you notice like you do a lot of, it's more of an artistic form of math in my mind because you do use a lot of calc and you use a lot of math and it's a lot of probability, which can be really intensive at times. But like, if you don't want to do those things, you can definitely just go into like analysis type things where you're just building out graphs. Like a business or data analyst nowadays, like they basically just make dashboards for people. But then for me, getting a PhD will give me a huge boost in my career because I'll be able to hopefully get a data scientist job, which is a very broad term right now because it's like the hot term, you know, like a data scientist, like,
Yeah.
And then it's like you have a huge spectrum of like job titles, but what I would really want to do is actually do statistics for someone like on the job because you kind of need a PhD to get to that level because so many people graduate with bachelors and so many people get masters, and so then they're mostly doing all the manipulation. But if I get a PhD, I would have the opportunity to be like doing meaningful statistics.
So do you want to run actual trials, or do you want to just take the data from the trial and make it so that it's whatever your company wants it to be, like the book says?
Yeah, there's a huge joke. I could tell it after, but I don't know. There's a whole field of statistics called Bayesian statistics, which is all probabilistic computing, which is basically predicting things. So my wife's uncle, he got his PhD at Duke, literally 36 on the ACT, perfect score on the GRE, 4.0, double majored math stat, valedictorian of class in college, went to Duke.
Smart guy.
Very smart guy. His dissertation was predicting the evolution in cells based off of using their mRNA. And so, like, that's what he did statistics with. Like, statistics is so broad. And so he worked with his professor to literally write, like, 3 or 4 papers on the evolution of cells and, like, proteins.
So it wasn't so much a commercial use of statistics. It was more of a scientific use then.
Exactly.
So that's the kind of side that interests you more then?
Yeah. And so that stuff interests me a lot. But again, like, I don't want to have to be a professor to do those things. And so I'm going to have to find, like, down the road, I'm hoping to find a line where I can, like, follow the trajectory of, like, being able to do stuff like that interest me, whether that's, like, renewable energy, which is something that I've become kind of passionate about because, like, makes my electricity bill go down if I got solar panels, so I'm all for it and stuff like that. Or if I can go into like a NASA type job, like working on something like that, because they all hire PhD students and like do all those crazy statistics, and like it's mostly probabilistic computing. Like Harvard, Duke is number 1 in the world, but every top, like Stanford's it's Harvard and Stanford, Duke, and like Columbia, all the biggest universities, if they're not already based on Bayesian statistics, they're shifting to Bayesian statistics. And Duke's number 1 in the world at Bayes. And so that's why he went to Duke, because he could have gone anywhere. But so they're all switching. So that's kind of the way I'm wanting to go. This fall, I'm taking the Bayes class, and then I'm taking advanced Bayesian statistics next semester. And then I'll go hopefully into a Bayesian PhD program. So.
Dang. That's crazy. That's a lot of school. I feel like I just can't sit. I mean, it took me, I graduated from college in when I was 27.
Yeah.
I mean, it took me 9 years to graduate from college. And was a 4-year degree.
Yeah.
So let's do some math here. So 9 years, 4-year degree. I mean, 5 of that was me just goofing around. But and I switched like 8 million times. That's kind of why too. I had so many credits by the time I graduated. But by the end, I just never wanted to see the inside of a classroom ever again. Like a PhD to me just sounds miserable.
The nice part is it's going to be free if I get it. And so like the nice thing is like school has always been something that's been like a drag for me, like all growing up. Like, cause I mean, high school wasn't challenging. Like I could just literally sleep all day and then go home, just kind of fake my homework and then study for 5 minutes before the exam and get an A. And I was like, all right, sweet. This is what school is. Like you don't have to try. And then in college, that did not work. After freshman year. Freshman year worked until college chemistry, and then I was like, oh my gosh, I got to start trying again. And so then I started getting into classes I actually enjoyed, and I felt like I was pushing myself intellectually. And like, that's when I started to actually enjoy it, but it was still like, oh my gosh, I can't wait to be out of here. And then I heard they can pay for your school. And so I was like, oh, I'm not paying for my PhD? Because what it is that researchers get grants from the government. And then they basically like hire a PhD student. And so they come on and do 2 years of school, which is basically a master's. Like every PhD, at least in statistics, you'll get a master's of stats before you get your PhD at that school, even if you already have a master's. And then the last 2 to 3 years is just research. And so you're just working with a single professor on your dissertation. And so yeah, they basically pay for your tuition and you get a stipend for teaching and TAing. And so it's basically a job. It's just a low paying job. And then the benefits are there. And like, I've really become like passionate about statistics and like the field, because for me, it's no longer school. It's like a science. Like it's something I'm wanting to learn more about. Like, oh my gosh, I want to know more about how surveys work, because I want to know and be able to read. Like, this is absolutely false. Like, most people probably don't know this. Surveys, you cannot use anything you get.
Yeah, surveys are not statistically significant. That's the word I was looking for. Like, nothing, because of the amount of personal bias that goes into it, collection bias that goes into it, and just, like, opportunity bias that goes into any survey, who that person decides to show it to, how they fill it out, the fact that it's filled out by your perception of yourself. That's always fun, because, you know, people fill out surveys based on who they want to be, not who they actually are. I mean, none of the data on any survey is statistically significant, which is, I mean, should be a no-brainer, especially after basically any political survey that's ever been done in the past, like, I don't know, 20 years. Like, how far off of election are they? They're like, oh yeah, this survey was conducted and we are you know, plus or minus 20%.
Yeah, it's like either one. Could have known that. Yeah. Well, the other thing is even statistically, if you had a perfect survey, you're not allowed to make inference based off of that survey.
Really?
Because you have to experiment. And so literally, even if it's like perfect, like no bias was involved, absolutely perfect survey, which is, as you mentioned, impossible. Even to be a person who responds to a survey, you have to be a certain type of person. And so that already throws it out the window, because I'm not going to go out of my way to answer somebody's survey, but somebody else might. And because of that, it's already biased. But the survey itself, you cannot make inference off of, like statistically. You would have to do a survey and be like, those look interesting. I'm going to make an experiment around that survey, and then I'll put that to the test. But like, even if it's a perfect survey, you cannot.
So then why do people spend so much money on surveys? I feel like,
I don't know.
Dude, they're giving away iPads left and right for these dang surveys. And you can't even, I guess they're more for, again, maybe like marketing. Because again, survey says, and then they just throw out their marketing. They don't have to say, like, studies show. That's probably the difference, is they, in the public's eye, again, the difference between a survey and a study is almost probably negligible. When somebody reads a headline or reads something on a toothpaste bottle, if it says surveys show or studies say, it's basically the same thing. But in actuality, by law, those mean two completely different things.
Exactly. That's what the book even goes into, because like it talks about how a Cornell professor, like Ivy League dude, knows what he's doing, did a study. Studies like experiment or surveys for me. So like he just did a study on this is the 1950s, but on racial divisions and based off of like if people thought that black people had a fair chance, you know, with getting a job, and then if they like he had another question that was like supposed to show their racial bias, and basically he did a study and like did it all, but he didn't make any conclusions because he knew he wasn't allowed to because it was a survey and he couldn't change anything. Everyone got the same question. And so like the way to use that would be like, okay, we see a disconnect from it, and so we're going to go run a different experiment where there's like a base. I can't remember the word of it right now. It's kind of embarrassing. Like an original exam, and then we're going to change one a little bit. So
something variable.
I can't remember, but basically it wasn't that. It was just a survey. But then the news article took his study and then said a Cornell professor found this, this, and this. And he did find that, but it was a survey, so he didn't make any inference based off of it. But then right afterward, it was like, so therefore we conclude this, this, this. And it's like, that's complete falsehood because you can't use inference based off of that. And the Cornell professor knew that and didn't. But since you're using the Cornell professor's survey,
so it's
then
like
it gives them credit. And
it
then
removes them one step from it, and then they're like, oh, it's not our survey. We're just collecting data from multiple surveys, and then it's a study.
Yeah, and it's a Cornell professor, so it's somebody who's really smart. So then if they use that in their marketing, it's like, holy cow, like, obviously they're right. But it didn't have any correlation, like, because there was no study, like, actually done. It was just a quick little research.
So out of this book, I mean, he covers a bunch of different topics within statistics and kind of all of the shenanigans that go along with people trying to manipulate data. But what do you see as the biggest perpetrator of lies that he mentions? Because I have my guess as to what I think the biggest perpetrator is. Actually, I think there's two, and I think they were both very evident in the past 3 years with COVID and with everything.
I think the top two for me would be graphical lies and percentages.
Okay, so go into those a little bit for those that haven't read the book yet.
Okay, so graphical lies was basically they manipulated graphs to make them look bigger or less significant based off of like the circumstances that they put in the graph. So like, for instance, you could have a 1% increase in your company, but then if you zoom in that same time span and then you zoomed it in 100%, it's going to look like it's a 100% increase, even though it's like 1% to 2%. But if you have a stinking zoomed in thing until every single little line on that graph is like 0.01%, it's going to look huge. And so to the average mind who doesn't, not even average mind, I would say to somebody who's not specifically looking for it, they look at it and like, oh, that's a big increase. Like that's a huge increase in like, say, crime rate in the newspaper. Like, oh my gosh, we need to fix that. And it's like 1% to 2%. So it's not that big of a deal, but the graph makes it look big, or say a pie chart that's not very accurate or anything like that. And then percentages, I just don't like in general because I don't know. I think it's not very useful. Like I'd prefer a fraction anytime I get a percentage because I understand those better mathematically. But basically just using percentages willy-nilly so that you can prove a point. And the biggest problem with percentages for me is also when they like start adjusting things. Like if you have $100 salary a month and you get a 50% pay cut, you get $50. Like you have $50 now. If you get a 50% increase, like sure, you'd think
you'd get your 50% back.
Yeah, no, but you're at 75% because it's 50% of the 50, and then you actually got a 25% decrease from what you started at.
Yeah,
and
those shenanigans kill me because that is inflation right now. Like what people don't understand is when they're like inflation decreased, because what is like the big term that everybody's hearing now, like inflation decreased, and they're using that exact same trick because they're like inflation decreased from 4% to 3.75%. And then you're thinking like, hot dog, man, inflation's decreasing. But what that actually means is that things cost 3.75% more still.
Yeah.
And they're using the word decreased and they're playing around with percentages, and it drives me bonkers because they're trying to spin something as not as bad as it is.
Yeah.
And they're just, they're lying.
It's funny too, because it's like, oh, it's decreased from 4 to 3.7. That 4% that happened also didn't go away. So now it's just exponentially getting more, you know, like it's now 7.7 basically, or like rough estimate. I bet it'd be around 7 because it's 3.7 to 4. So now it's actually 7% more than it was a year ago.
Yeah.
It just mathematically doesn't make sense for me, but
well, it's annual, so it's from month to month. So it's like it's 4% more from April 2003 to April of 2002, 3 from May to May. Mm-hmm. And so it's just,
See, that doesn't even make any sense why they'd make it that way then. I don't know.
Yeah, I mean, it's terrible because the year before, I mean, there hasn't been a negative inflation in so long. I mean, you're year over year just paying more and more. I mean, it's crazy. I mean,
But again, that's what people try and do. Like they try and make it different. Like I didn't even obviously had a clear understanding of what inflation meant because of all the different demographics that we face. Like I probably should look more into it, but
inflation's a crazy one with statistics because every president tries to decrease the significance of the inflation, and the thing that they focus on is the change in inflation from month to month. But in actuality, that doesn't matter because inflation doesn't even measure the change from month to month. It measures the change from year to year. And then they're focused on the numbers from month to month as if that has any statistical significance, even though that's not at all what you're measuring.
Yeah.
You're like, it's like if you were to take the change in size of apples and oranges, and then compare those percentages, it'd be like, well, what does the change in size of apples have to do with the change in size of oranges? Absolutely nothing, except for that they're both fruit. I mean, they're not even grown, like say they're grown on opposite sides of the world even. And you're like, well, the difference is only 0.1%. You're like, I don't care. They're not even comparable. Like that's what they're doing with inflation. Like it's not even that month to month those numbers even matter because you're not even measuring from month to month. You're measuring from year to year. And so again, I think that this is just the economics brain in me. It's just, it drives me nuts because I'm like, inflation. Yeah, I mean, these people out here like inflation has decreased, and you're like, no, we're still paying 3.75% more than we did last year, and it's like you don't even know what that change is because they're measuring on a change from month to month. Could have meant that a year ago, inflation went up. Does that make sense? Like, what if the change from April to May last year was a big spike, and then your month from April to May this year was flat, and then your inflation rate over the year actually decreases because last year it was higher than the month previous, and so your change in inflation over the year has actually gone down because it's closer, when in actuality the actual inflation rate or the actual price of things is the same.
The same. Well, it's probably getting,
Like, isn't that insane? Like that number means nothing. Like the prices of food could actually just not change at all. And they could claim inflation is decreasing.
Yeah. That's crazy.
Because the numbers mean whatever they want them to.
Yeah. Like the joke, I don't know if you want to hear, but the joke in our statistics department is that there's these 3 people trying to get a job, and one of them was a mathematician, an accountant, and then the other one was a statistician. And this goes along the lines of people who use these bad tactics. But basically, the mathematician walks in, and the guy's like, "What's 1 + 1?" And he gets out a piece of paper, writes an equation down. "Oh, it's 2." He goes, "Okay, thank you. We'll get back to you." The accountant walks in. He goes, "What's 1 + 1?" He whips out a calculator. 1 + 1, puts it in. "Oh, okay, it's 2." The statistician walks in. He goes, "What's 1 + 1?" He gets up, looks out the window, thinks a little, closes the blinds. "What do you need it to be?" And then he goes, "You're hired."
That's so true with statistics. It's crazy what they do with these numbers.
Yeah. Luckily, I go to a school that is pretty good about it, but so we're always talking about like what could go wrong. And I think a lot of things is they don't realize what they're doing a lot of the time, because like
Really?
if you pound the numbers down enough, you'll get the things you want. And so like,
But you don't think that the government knows what they're doing with all these like number tomfoolery? You know, like I think they do.
well, did you hear about Stanford and Harvard professors?
No.
They know what they're doing. They definitely know what they're doing. So a Stanford president just stepped down like 2 weeks ago.
What
As
happened?
president, he faked his data. He was a neuroscience guy, brain dude, and he copy and pasted evidence like and increased the saturation in his reports, and like just zoomed in. Like one of the things was like, here's a neuron. Like we're gonna try something and then see if the neuron grows. And then he had the same exact picture, but just zoomed in, so then it looked like the neuron grew.
Oh my God.
And he got caught by a Stanford freshman writing for like the Stanford Review or Stanford Post. And he was like, why is our president writing these weird papers? Like he's the primary author. So then he went to an independent person and like they investigated it and they were like, yeah, we concluded these are absolutely false. And it opened like a field of neuroscience, these papers. And that's what he got famous for. And then a law firm went in and like checked everything, and they're like, oh yeah, these are all definitely like faked, but we can't prove that he was the one who did it. And he was like, obviously like, oh, I didn't know this happened, but he's like the primary author. Like, come on. And then he stepped down because he felt so bad. And it was like 3 or 4, like 5 of his papers were all just like bogus. And then at Harvard, an economics professor literally faked their data. Like these 3 professors kind of got annoyed. They were all professors of economics, and they were like, this person got really famous off of weird findings, like things that you would read and you're like, oh wow, like there's no way you got a 0.1, like 0.001 significance level. Like that's really low for something super wild. But basically she literally inputted data, like say like for one of the things, it was like, what school do you go to? And like this, what year in school are you, a freshman, senior, like this. And then they were responses in numerical ascending order. So it'd be like 1, 1, 2, 2, 3, 3, all the way up to like say 10. And most of the graph was like looked pretty good. It was a general like scatter plot all around like a linear regression model that was pretty accurate. And then there'd be like 20 points just completely away from the whole plot and just super extreme that completely changed the entire like study. They go into the data and it's like, what year are you in school? Harvard. And like not in ascending numerical order. So it'd be like 10 with like all the 2s, and like 3 of her papers that she was a primary author at Harvard are like immediately suspended and she got fired. Like
Just for
completely bogus studies. And so like it's not even government. And like my thing, like obviously I like school, but like does that mean that like the classes they taught were lies? Like no. Like obviously they knew what they were doing. They understood the field, but they took advantage of the fact that if you get significant papers that make waves in their research field, you're going to get hired at Stanford. You're going to get that president job.
It comes all down to money. Like,
Yeah.
dude, it's money. And it's like once money gets involved, and I think that's probably what makes school so wholesome when you said that, you know, like my school does a really good job of making sure that we understand this. And it's easy to do that when kids are paying you to teach them, you know what I mean? But then when it comes to like working for a cereal company, and they're like, all right, like this is your job to feed your family. We need you, like you said with the joke, like close the blinds.
Yeah.
We need you to tell me that Captain Crunch is the healthiest option for your kids, and that kids that eat Captain Crunch grow up to be stronger, and that all major athletes eat Captain Crunch. And so like that's when it becomes a little bit suspect.
That's unfortunate, and it does happen because there's a very famous distribution called the T distribution. And so like before that, it was all about Gaussian guy was Gaussian, I don't know how to pronounce his name, he's European. I think he's German. He had a distribution, and like there's the Z distribution, which is based off of knowing the parameters of your study, which basically means I need the population's whole numbers in order to know like the statistical importance of something. And what happened is this dude, he was working for a brewery and he wanted to, like, he knew that it wasn't right. He was like, how can I honestly know this, like the parameters, like the whole population of poppy seeds or something like that? Like I can't even do statistics, and that's what I was hired for. So he came up with this whole new distribution, and it's like crazy accurate. Like it's perfect, honestly, for what it is. And it's the T distribution, and it opened a whole field of statistics basically. And what it is, it used the standard error, which is the standard deviation of the sample. So it completely changed it to where you didn't need the whole population's information, to where you only needed the information about the samples you were getting and like stuff like that. And the people who he worked for were like, this is great, use it, don't publish it. And it's like, don't publish it. He was like, what do you mean? He's like, you will get fired immediately because we do not want our competitors knowing this. And so he was like, okay. So he published it, but under student. I can't remember his name. All I remember is that student published it, and it was the T distribution, and it changed statistics. But like, there's definitely incentives behind certain things in like these fields, like math, statistics, economics, physics, even. Like you wouldn't know, like, oh my gosh, like an economics professor at Harvard literally faked her data so that she could get promotions at Harvard and became a faculty member, like higher up, like the Stanford professor. He was just a normal guy at Stanford, and now he's the president of Stanford because he made all these important findings. Like, it is about money, like in the end, or like prestige. Because like the brewery didn't want the competitors knowing, like, hey, if you use this distribution, you'll understand your stuff way better. And so then they wanted to keep it a secret, but he knew that it was more important to advance the field of statistics. Mad respect. They figured out his name. Don't remember his name. Probably should know the name, but
Nice.
But yeah.
So I think, though, if I had to pick two of the things in the book that I felt like everybody should know or have like a base understanding of because of the amount of shenanigans that go along in media, news, whatever it is, I would say the difference between mode, mean, and median.
Yeah.
I mean, that one kills me because they all mean average. And so people always think like average means you take them all up, you add them all up together, and then you just divide it by the number of things that you added up. And you're just like, well, that was the average when we were in like
sixth grade.
Like that's what they said, because that is one of the averages.
Yeah.
But average, you can get the average multiple different ways. I think it's really funny. I saw this, I think I showed you that Instagram reel with that Asian dude that was like, talking about the average and how not all Asians can be above average in math.
Oh yeah.
And he's like, he gives the average score, or he takes the entire population of Asians, and he's like, you can't fit all of those within the top 50% of the U.S. or of the world. So like, it's not possible that all Asians could be above average because average is 50%. And then another Asian clips the video and is like, well, let's do a different type of average. We're going to do a bimodal distribution.
Yeah.
We're going to take everybody and we're going to create a new way of doing the average. And that, I think, is important for people to understand, is that average isn't, it's not just total distribution, like averaged out. I mean, the mean, that is the mean. And then you've got, the mode, which is whatever
The most frequent
number.
Yeah.
And so, if you hear, as an example, a company say that the average employee at our company makes $130,000, and then the way that they're collecting that data is that 130,000 is the most frequent number that they pay people, and say they only pay 10 people $130,000, and then they pay a lot of people, 70, 60, 50, 40, 30, and then, a couple people, 200, 800, like 1,000. And then they're like, well, the average is 130 when their actual like mean average could be, less than 100.
Or the median, which I feel like is the most important to me.
Yeah, and the median then is the middle number. So when you get rid of the highest number, the lowest number, the next highest, the next lowest, the next highest, the next lowest, and then you find the one that's smack dab in the middle, the median, that is that number.
Yeah.
And so you can find the average really any way you want. And my guess is that in almost every study, and I don't know why you wouldn't do this, they probably find all different, all three. They do bimodal distributions. They do everything they possibly can, come up with a bunch of different numbers. And they're like, okay, which one's the most favorable for us?
Yeah.
And then they blanket term it under the word average. And just nobody gets that kind of distribution and that, has that understanding. And they just instantly think, they go back to 6th grade and they think, okay, well, that means that, on average, I'm going to make, $150,000. And that's just not true.
I don't even think they go back to 6th grade and think about the math of it. I think they literally just go on average, like, oh, that's what the normal person makes there. Like,
yeah, that's what the normal person makes there. Yeah, it's not even a math. To me, I think of everything in math. So I guess you're right.
I know we're both like that, but I don't think that now I'm going to use the obligatory average person thinks like that.
Nice. Yeah, so that one was one that I feel like if you don't understand the significance of that, this book does a very good job. And also the nice thing about this book is that it's like 20 pages long, I feel like. It's not 20, it's 140 pages long. It's a quick read. I read it in a day. Yeah. So it wasn't bad at all. But I think if you don't even understand that as a bare minimum, I think this book is a must read because of the importance of that and the amount of tomfoolery that goes around the word average. So I thought that was really important. And then the other thing that he talks a lot about in this book is how statistics are completely useless and invalid when you omit information.
Oh, yeah.
And I was just like, well, really?
Yeah.
I think they should have read this book before they released any COVID statistics.
Yeah.
I mean, it was just he was talking. I mean, he literally gave examples in this book of there was a study that was done. I can't remember. I think it was measles, mumps. I can't remember.
Yeah,
or the flu or something. I can't remember. He literally gives an exact replicated study of what happened with COVID where they just blow out the number out of proportion and then just don't even account for, he's they don't account for comorbidities. They don't tell you what the average death rate was before it happened. They omit basically all of this information. And then they just blanket it with this percent of people or this many people and this percent of people are dying.
This percent, that's what kills me. It's always a percentage.
He was like, this study is a joke. He's like, if you dive into it, you realize that it had there was no statistically significant change. I was like, oh my gosh, if only one person in government had read this freaking book to realize that if you just omit everything and then focus on the one stat that you want, and you throw it into a percentage and then run with it and you omit all of the other data behind it, then it just doesn't mean anything anymore.
Yeah.
And I think that happens not just with COVID, but I think that happens with so many things. You can make a statistic mean anything. He talks about in the book also how if you omit the relationship between things, you can statistically say with confidence that, the amount of men born every year increases by a percentage or increase, if the greater percentage of men that are born every single year increase global warming, therefore men cause global warming.
Yeah.
And he's like, if you just omit all of the fact that statistically over the years, the percentage of men has been consistent.
Yeah.
And global warming hasn't been consistent, you would know that has nothing to do with global warming. But if you say, there's a greater percentage of men on this planet this year and global warming has gone up this year, then you can
fault.
you can write an article about how it's Ben's fault.
Yeah, we talked about that a lot in my linear regression class, which is more focused on like building out models and stuff versus probability. But yeah, like you really have to like some part of statistics is literally just. Oh, it's my phone. I'm sorry.
Unprofessional.
I thought I silenced it. It's probably my buddy who's texting me about Dune. We talk about it nonstop.
That's got to be our next book.
Yeah, it should. But basically, like at some point, it's literally just like not common sense, but statistical sense. Like because they talked about, like you said in the book, there could be a very high correlation. An entire study could be done that the building of like say skyscrapers in New York kills the cat population because cats are dying because of some like flu, but they don't include that in their study. But then skyscrapers are building, so skyscraper kill cats. Like it's like so ridiculous. Like what? But yeah, it's so at some point you do just need to be like take a step back from all the math of it and be like, okay, does this make sense? And that's when you kind of fully understand statistics. I feel like is because once you realize it's more than just numbers and like more than just a distribution, more than just this correlation coefficient and all these other things, it's like, how does this actually apply? Like if I go to my boss and he asks me to find something and I'm like, okay, we found this. The significance level, which is like a blanket term for if it's lower than 0.05 usually, and 0.05 is like an arbitrary number that one professor decided on. It's not like a sound thing. But so like if anyone's like 0.05 is like the number, it's like, no, that's just everyone can just because I was like, all right, yeah, sounds good. It could have been 0.1, who knows? But if you have like a significance level you set, which is also another very important thing, you have to set it before like you run a study. Because like say it's not super important, you do 0.1 as your significance level. If it's lower than 0.1, then I can say with a confidence 90% of the time like that this is going to be the case. And so it's most likely not that. But like say it's something with life and death, then I'm going to set a significance level of 0.001 because I want to make sure that I know that that's not going to kill somebody, you know? But if the significance level is 0.05 and then my boss tells me to do something and it's like, all right, I got a significance level of 0.06. Nope. Sorry. Can't make any inference based off of this. Basically, we don't know. And my boss is like, it's a 0.06 instead of 0.05. I think we can accept it. And it's like, no, statistically, you can't. And it's like, at some point, you kind of just need to be like 0.06. All right. Yeah, that's good enough.
Yeah.
Like, you need to think outside of just numbers. And like, I think that's something the book focused on a little bit, but I think it should have focused a little bit more on. Most of the stuff, it's written in 1954, but most of it dove right into the math of it, which is really good. But I think at some point you do need to take a step back from the math and be like, oh my gosh, this doesn't matter at all. Like, yeah, it doesn't. It's not important. It doesn't make any sense. And even if I didn't understand the math, I don't care because it does not affect me. Like,
so then, I guess after reading this book and with your kind of experience with statistics, how can the average person look at anything either with confidence or with skepticism? Like how should they approach anything, any sort of study or statistical number that's given to them?
This is from not even a bachelor's grad, but from what I've seen and what I've done is basically just look for the best in a sense, like have faith, but try and prove it wrong. Like if you can, like don't be cynical about it because like it's hard to have a perfect study. Like everyone knows it's impossible because that would require 100% cooperation. And like you could, like there's a study in the 20th century of like syphilis and it was like they gave people syphilis and like other things and like they're like, we'll see if this helps it, and so we'll have to give them all syphilis and we'll have some people not treated and some people treated over the next 70 years and see what happens. And it's like
pretty unethical.
Very unethical. So like basically every study is like hard to do. And so that's why I like Bayesian statistics because it's probabilistic computing, which means I don't have to deal with that. Like it's mostly dealing with stuff that will most likely happen. Like I like probability way more than other stuff, but I would say believe in people and that they're actually trying.
So don't read this book and then just be like, well, everybody's lying to me. I'm never going to believe anything ever again.
Yeah, like I wouldn't do that. But also when you see a statistic or hear statistic, definitely try and like think about it and like be like, does this actually make sense? And even if it doesn't make 100% sense, like mathematically or statistically, does it make sense commonly? Like in day-to-day life, does it make sense? And that's when I kind of just like draw the line. It's like, all right, does this actually make a difference? Like, would I believe this if I didn't have the numbers behind it?
I think the other thing to keep in mind, because I definitely went down a rabbit hole of just everybody's lying to me.
Yeah.
Like, screw it all. Everybody's lying to me all the time. I went through that phase probably 2 years ago. I was like, screw this. Everybody's lying to me. But I think I've changed my mind. And I haven't changed my mind. Everybody is lying to you. But in every lie, there are nuggets of truth. Yeah. And I think that that's what's important to get out of the statistics, is to look at them, understand kind of what people want you to think, and then try to pull out the important things out of that, because you can learn a lot from you can learn a lot still from fake statistics too.
Yeah.
Because you can learn intentions, you can learn, what people, and behind every fake statistic, there are real numbers. That's the other thing to remember, is that statistics and the way that it's portrayed in this book and the way that people use statistics, they take real numbers and real studies and then they bend them to be
what they want.
And so there are still real numbers behind them. So just kind of understanding and taking kind of a step back and being like, okay, what could the real numbers be to get to this point? And then you kind of have a good idea of what's actually happening, and then understanding from the real numbers the conclusion that they got, and then you can kind of understand their desires in there too.
Yeah.
And so then you can kind of be like, okay, well, if that's their desire, then they probably did this and probably did that, and then it all starts to make sense. Like the CEO of a company saying, we're going to offer, UPS saying, on average, everybody's going to earn $170,000. His goal is to probably hire more drivers.
Yeah.
You know what I mean? Like there's definitely a shortage of transportation. People order more and more on Amazon and they need more and more drivers. And so his goal is to get more people in the door, which means those are going to be overinflated numbers. And as long as you understand that, then you're like, okay, behind that, there are real numbers. They are probably still increasing salaries. They are probably still increasing benefits, but maybe not to that extent. You know what I mean? So as long as you understand which direction people are leaning, then I feel like you can take a step back and be like, okay, I can critically assess the situation, understand people's motives, and then get a better idea of where the base data is coming from.
And also knowing that those people may not know what you know about statistics. Like I'm probably very a part of a very small percentage of Americans or even people in the world who reads books about statistics for fun. So
yeah,
I probably know a lot more than most people. Even like a CEO of say UPS probably knows the difference. Someone down the road probably told them like, hey, like this is what we can do. But say somebody who doesn't know the difference and tries to write an honest article and it is deceptive, but not purposely, it's like done in ignorance, then like why would I be super mad at that person? Like you kind of have to like gauge of what they know. And so like that's another thing I'd say. And like I don't know, I'm a firm believer in just believing in people rather than not. And like, that's kind of what my thought process is. But like, I can see why it's definitely not, because it's really hard nowadays. Because I feel like everyone tries to shove things. And also,
how can you be the number one? How can every brand of toothpaste be the number one brand of toothpaste?
That's what kills me. The car companies, this is the Ford truck of the year, like Ford F-150. It's like Chevrolet. This is the Chevrolet award of the truck of the year.
Well, did you know that most car companies create their own awards?
Well, that's what I'm saying. They all create their own awards and then give it to their own cars.
Yeah, and they're like, the last 5 years, this has won the whatever award, and it's like, and they give it a fancy name, so it sounds like the motor truck award of the year, and it's like, that was created by your company.
Yeah, exactly. But I can't. Yeah, that part's really funny. But basically, I would just have faith in people, hopefully. And the other thing is most people aren't statisticians, and so they don't even understand. But when they have a statistician on board, that's another good thing. Like that's what my professors told me. Most people, like obviously there's a few outliers, like say that Harvard professor or Stanford president. Like there's outliers to everything. But if of the like some thousand or hundreds of schools in the US who have PhDs in statistics and they're on a research, they're most likely going to be ethical. Like the probability of that's higher than not because they went into the field with respect for the field and a desire to do more with it. So if there's a statistician on the research, then it's most likely going to be better, and it might be even harder to catch if they're not ethical because then they know exactly what they're doing. But if it's peer reviewed, it's another very high, respected, like most likely going to be good. And like again, if they're making crazy inference based off of the study, you can pretty much like be like, all right, this is a little sketchy. Like if they're just making small inference, like, oh, we decided that, I don't know, like this little small tweak in toothpaste is like a 2% increase in this. It's like, all right, that's not bad. But if it's like, oh, if you use this, then it's going to whiten your teeth by like 100%. It's like, I don't know. Like that sounds kind of fishy. Like big claims, usually big deception in my mind.
Yeah. So what would you rank this book on one? So first ranking, fun to read. Second ranking, importance.
Fun to read for me or like?
Yeah, for you personally, not for other people. For you, fun to read, and then importance.
Fun to read, I would probably say like a 6 or a 7 because I'm very much into fantasy. That's usually what I read, like Dune, Lord of the Rings, like all those type books I've read and all that. And so I'd say like a 6 or 7 because for me it is fun to like see all the studies and like kind of make fun of them. But importance, I would probably say like a 9 or a 10, honestly, especially in today's age. Like this was written in 1954. Like, yeah. But now it's even way more prevalent because like back then you got a newspaper once a day or once a week. And like,
I mean, now, yeah, I mean, I saw those statistics literally scrolling on Instagram. So, I mean, they're everywhere.
So you need a
Twitter's all over it. You know, it's crazy.
It's X now, but I mean,
whatever.
Yeah.
I'm not up on that.
But, yeah, I would say it's like a 9 or a 10 because if you understand these principles, then I feel like then you're starting to critically think a bit more. And that's not saying people who don't know this don't critically think, obviously, but I feel like it elevates you to such a higher level and like being able to see through people's deception.
Yeah. I would say for me, this was probably like a 5 fun, honestly. Like I feel like I already knew most of this, just again, taking high level math classes, kind of living in the world of math for a while. I feel like I knew a lot of it. So a lot of it was review.
Yeah.
But as far as importance goes, and if you are just kind of unfamiliar with basic statistics, and because that's the other thing is that it is very basic of a book.
Yeah.
Like it is written so that people who don't have backgrounds in math can understand it. So me reading it, I was like, oh my gosh, like, yes, you're explaining what an average is. Like I've known this forever.
I know what the mean is.
Yeah, exactly. Like we don't need to go into detail about it. But I do understand the importance of that because like most people are not math people. Math is one of those subjects that like a lot of people just don't love. So for me, I would say it was like on a fun scale, probably a 5, honestly. But on the importance side, I would agree with you. I do think it's a 9 or a 10 on importance. The fact that it was written so long ago is crazy to me because it is still just, I mean, it is so important. And the nice thing is that it's 140 pages long. You can read it in a day. And I think it will change the way that you look at a lot of studies and a lot of communication that comes out of, different companies, out of the government, out of really anywhere. Social media, it'll change the way that you look at it. And as long as, like you said, you don't spin it to be just living in that negative world that I kind of found myself in a couple of years ago, where you're just like, everybody's lying to me. As long as you don't do that and you just take this book and you take it as like, okay, I'm just going to use this to kind of elevate the way that I think about things and just take a little bit of a step back, but still have faith in people, then I think this book is great. So for anybody that doesn't have that background in math, I would highly recommend this book because I mean, it does a really good job.
It's very clear
And
it's not
very easy
confusing.
to understand. Again, if you're a high level math person, you'll cruise through this and be like, I mean, all of this makes sense. But it also is just a good reminder. I mean, some of the things in there I was like, okay, like that was a good reminder. Yeah, it's good to look at things that, and kind of have a different perspective on some things. And so definitely an important book. Highly, highly recommend it, just as kind of a basic understanding to the way that businesses talk to you. Yeah. Because, I mean, everybody's doing it.
Yep. And it's also important to just like, I don't know, like I feel like it's important to see examples, because like you can learn this in a math class, but if you don't have those examples, it's going to be harder to recognize those in the out in the wild. But I mean,
and that is one thing that the book does. It pulls tons of examples. And so that was good, I will say. And that was, for me, the most entertaining part of it was, again, all of the examples. So yeah, I mean, very easy to learn, very important topic. Definitely would recommend this one. 9 or 10 for sure on the importance scale of things. Awesome. So are we reading Dune next? Is that
Let's
gonna be
do
our next
it.
book?
Yeah.
For real?
I just finished it, but I could read it again. I'm already reading the second one. It's like,
okay.
Yeah, it's so
I mean, unless there's a different fantasy. On my list, I definitely have Dune and Lord of the Rings.
Yeah.
Which one out of those two would you say is more
fun to read?
Yeah, more fun to read.
Well, Dune's way more fun to read. Lord of the Rings is kind of thick. But I mean, like, as a kid who watched the movies every day, like 2 or 3 times a day when I was like 5, Lord of the Rings is my favorite.
That was like on repeat in our house. The Twin Towers on repeat.
Disc 2, specifically. Starts off with the wargs attacking the room.
I know, seriously.
Yeah.
Skip all the boring stuff at the beginning. Just go straight to battles.
Yeah.
I just want to watch the wargs and Helm's Deep over and over and over again.
Yep. That's what it was every day.
No, so Dune's more fun.
Yeah, I think Dune's way more fun to read. It's way more intense too. Like, yeah.
Well, that'll be our next book. So we'll have to come up with another date for that. But definitely go out, and if you haven't, I guess, picked up this book or anything, I think you can get it on Amazon for like $2. I was looking.
Yeah.
It's pretty cheap. So,
yeah.
But it is definitely well worth the read just to kind of better understand things. So, thanks for listening to this episode of the podcast. Make sure to like, comment, and subscribe to it if you haven't already. And as always, I'm, looking for guests to come on the podcast. So, anybody interested in reading a book with me, sometimes I'll let you pick. Sometimes I pick the books because there are books that I want to read. And I have a list of probably 100 books on my list. So I've got a lot of books to go. And so definitely reach out if you're interested. Otherwise, tell your friends about the podcast, looking to grow. So make sure to let them know and read along with us. I think I've said this a couple times that my website is up, and it is not. So, but it will be up hopefully by the time this podcast is live. So I'm so close to getting it up, and there will be a calendar with like the next 6 books that I'm reading. And so you can read along with the podcast, read the book before the episode, have fun with us listening to it. And so, definitely stay up to date with some of the updates coming with the podcast, hoping to be able to collect some questions, get the audience involved a little bit more. So that requires a bigger audience. So definitely tell your friends about it. And thanks for listening.